and available. I'm going to assure you of that. What a day. What a day. Yeah. Unfortunately, it's costing me X hundreds of dollars an hour for these guys outside. This is the most exciting part about it. So anyway, back to our little game here. So we have our little friend now, and he's doing the right thing. And as our hero walks across the screen, gravity pulls down, and our little environment thing also falls down, and it's kind of cool in that at least he comes down here. He can push it. Look at that. So he can push the environment. Why? Because he has a collider on him, and he is moving according to a certain velocity, and the colliders interact, and he is able to push against something and impart his same velocity to that object, depending on how, what the mass and so on of that project, that object is. But let's do something more spectacular than that. Say we have this thing up here, and we want to make a trap. It's a trap. And the trap is going to be a simple one. The trap is just going to be that somehow, if the player steps on it, it will fall down. Easy enough to do. Now, that would be one thing to do it with a trigger and a collider and all these sorts of things. But could I do it with just a plain joint? Just add one simple object. And the answer is, of course we can. The thing I'm going to add is something called a friction joint. Very interesting joint. And by default, it's not very strong. So I'm going to make it a little bit stronger. I'm going to say, okay, the maximum force that this is going to resist before it moves is 10. And I am also going to make sure that the rigid body for this object is not going to rotate. If I allowed it to rotate, it's going to be a little bit weird. So we're going to not allow it to rotate. But the cool thing is now that it has this friction joint that's going to resist with that factor, you will see, hopefully, fingers crossed, that once the game starts, the platform just stands there because it has friction on it here. Now, if the player, let's see, he carefully walks across, well, he adds enough force to make it fall. So let's make it resist maybe a little bit more, maybe 20. Let's see. So we can get this to the point where if he tiptoes across, he can make it. Let's see. So we could potentially get across. Now, if he jumped up in the air, he would exert more force there, and things would fall down. So if we were running along here, or we were potentially maybe carrying another object, or something was going on that caused us to not be able to carefully tiptoe onto this object, if we just even took a little bit of a jump, it would fall. So we could set up this sort of an interesting environment even. What if we did this? We said, okay, it's this far across. So we have to jump to get to it. But we have to jump to land with a minimal amount of force. So we don't want to jump awfully high. If we just jump just enough, that's going to be too much, and it falls down. So we could tune now. We could say, okay, what is the maximum force that we want it to resist? And then come up with some sort of algorithm to say, or at least some parameters for us to say, okay, we can at least accomplish it, would be the goal. It should be possible to get past this trap. But you can imagine now, it's something we can design into things. So the friction joint is a pretty simple one. It's basically, it's a joint, quote unquote, that joins the object to the environment in this case, because you have two options with joints. They are either joined to the world, sort of the environment, or they're joined to another rigid body, right? So by default, when you don't assign a rigid body to it, they are just assigned, they're just in the world, right? So they will move with regards to where they are in the world. Now, in friction joints, they just want to kind of resist motion and kind of sit at a certain spot. So they're pretty straightforward. Now, you'll notice a couple of things in here. There's like maximum force, maximum torque, right? So you can have it resist spin according to it as well. And so if we allow this to rotate, do some things like that. And also there's this, most joints have these braking forces and braking torque. And what those are is it basically says, okay, if you exceed this amount of force, this amount of torque, the joint just deletes itself, destroys itself. So if you hit it hard enough, it effectively just gets rid of the joint altogether. So you wouldn't be like riding on a friction joint, kind of moving at a nice steady pace where it's sort of, trying to, if you exert enough force, it would just, you'd break it free, sort of thing. You can do that. So you'll see that those parameters, these kind of brake force, brake torque, in most of the joints. But let's look at another one, similar, sort of useful one in terms of platforms. So we're going to just disable that one for starters here, and let's put in a slider joint here. And I like to a lot of times just say, okay, well, let's see what happens. If I put the slider joint and I'd hit play, what's going to happen? Not much of anything. It doesn't look like anything's happening, at least. But if I walk over here and jump, and I get there just enough, I can impart a sliding force to the thing. And let's see, it's kind of tough to catch up to. I need him to walk faster. So first things first, I gotta make him, maybe 5, and yeah, he's not in linear drag, so he's gonna move a little bit faster, and his jump force is way too high. So let's set that 20, and all right. So now he's gonna come across, and we will jump. Oh, well, I'm gonna just do this power jump here. Oh, he's not moving fast enough. That's the joy of these things. Let's try it one more time. I should have moved it just closer. So, yeah, there we go. Boom. And now I've landed on the platform, and you'll notice if I try moving left or right, the platform actually moves with me because I am in contact with the platform. So I'm trying to change my velocity, and it is traveling along with me because it's kind of stuck to me. There's just enough friction between me and the platform to cause the platform to move, and it has this sliding joint that allows it to move back and forth. Okay, you see I can kind of sneak my way off of it because it's not infinite friction there. It's just enough. And if I hit over here, you'll see now I can start moving again because now this collision here, this contact point's going to resist it. So you could do some clever things with, moving joints back and forth. And if random forces hit this, it would slide along there. So let's see what those parameters are for that sliding joint now. This is another example here. So slider joint also has, you'll see down here, a brake force and a brake torque, so that if you hit it hard enough, it will destroy itself. But the important things about it is that it will have things like, anchor, connected anchor, whether or not it's attached to a rigid body. We're just using them in the world. But here there is this angle and potentially translation limits. So if I turned on limits for a second here, and let's kind of zoom in. Okay, so here's our slider joint, and we're going to say, go ahead and use limits. You'll see it's kind of hard to see. There's a little line there. Maybe if I switch to that. There's this little line here. Slider joint. Use limits. And you'll see it sort of becomes a little stopping line here, which is going to say, okay, it's allowed to move within, right now we have that little circle, which is our anchor point, and it's allowed to only move between 0 and 0 at the moment, which isn't awfully effective. So let's give it a little bit more of a range here and say, all right, you're allowed to move between, say, between 0 and, 0 and 5. I'm going to make it 0 and 5. So now in our game, when we press play, If we jump over to our other bridge object here, we'll see that it will move, but it will eventually hit a limit. It can only move 5 in that direction, and if we zoom out, we can sort of see these limits here, right? So as I'm moving, you can see it limits the amount of motion before hitting that point, and then it becomes rigid, right? So I have a range of motion for the slider joint. It also has some momentum to it, so I left it kind of moving there. But it's nice, you can cause it to force it to hit limits on it, right? So it's kind of what end of the motion do you want it to be on, right? So we'll kind of do it again here, kind of move it along, and you see here's the anchor point. When we hit that, it's going to stop, right? Boom, and now it stops. We can move in the other direction, and this anchor point there again, when it hits that limit, boom, it's going to stop, okay? And if we looked in the real, as we're editing it, we could even change where the anchor point is. Right now, the anchor point is at the center of this, or what the world considers this object to be at. And we could even kind of fine tune that and say, well, okay, the center point should be, somewhere like there, more the center of the platform. Right? And so now when we move, it's going to move a little bit more within that range, centered according to that. Yay! Kind of slow motion. Don't fall. All right, so it's going to move there, and then we can move there, and we hit the limitations. Okay, we have enough play here. We could have gone even further there. So now it doesn't have to be in a straight line either. Well, excuse me, it does have to be in a straight line. It doesn't have to be in a horizontal or vertical. You can do it at angles. Right now, the angle right now is 180 degrees, but we could certainly change that. And we want to turn off auto configure angle now. So if we wanted to do it so that it could only slide along this line, right? And now it would be interesting because gravity could potentially impact it, right? It can move along that line. Gravity's pulling it down. It gets to be a certain distance, and it's going to move in that direction by itself because of gravity. So the issue now is that, well, when we hit that, we're just going to add more. We're at the limit. We can't do anything. But if we were to get to the end here, we might be able to, depending on things, nope, can't quite do it. I was going to say, if we could exert enough force for it to overcome in this direction, force it to kind of go up the line that is defining it, and we can't quite do that. So this is a case where we might want to add additional things, like say, wow, okay, let's use a friction joint with a line joint to say, okay, resist, but you can only move along this line, right? So you can kind of force different combinations of effects by doing things like that. Another thing you can do, though, you'll see there's this thing called a motor. And what a motor is a sort of a built-in engine, motor, motion, something that's going to provide motion that's going to sort of resist gravity here. So we'll go ahead, we'll give it a motor speed and use motor. And, well, let's see, do that when it's not running. And it's going to want to move along that joint, right? So you see it immediately moved it down, so we had the direction wrong. So instead, we want it immediately moving in that direction. And it will start to go in the opposite. All right. So now if we were to come along and jump on here, you can see it's trying to move down, trying to let it move in that direction, but this -10 is forcing it back up again. So what if we made it -2? Well, now we're already sort of kind of all. When you specifically set limits, that's where that kind of comes in. Like right now, I'm just setting it at an angle so it can move along that angle, but I have no limits, right? So if I select that object and I'm working with the slider joint, then you can see it doing its thing. Now, right now it has a motor tending to move it in that direction. So even though it doesn't have a limit, it hit that, and so it effectively had a limitation there. So I can come along and see, well, if I have enough force now to overcome that motor, which I can't, I guess not enough force here. So let's see, let's limit the amount of force that it's going to be able to come up with to like 10 and -1. And should be possible to come up with a set of values that we can sort of overcome. So let's try that. I'm going to give it just a tiny bit there. Oh, not enough. So let's say 5. All right. All right, so now I'm on there. I am moving against the motor. If I jump off of here, you'll see it's going to want to move under the force of its motor, but I can also use my force to move it in a certain direction. All right, so this is all the physics interaction now. So it can only move along that sliding joint, subject to the force that I'm exerting down to keep it going in that direction and along that direction. And then if I jump off, it's going to use its motor to try to return itself or move itself in that direction, subject to any collisions. Right? So it's really kind of neat. You can create different shaped objects and kind of all sorts of things just automatically without scripting anything. That you can have these very interactive environments. Right? You can even do things like this was the sliding joint. Another really fun one are the let's see. We'll add a hinge. Hinges are fun. So by default, let's show you what a hinge will do. And in the case of rigid body, normally you don't want to have the rotation limited because hinges are all about rotation. So I'm going to probably come up here and whoops. Yeah, I guess I'm more like flying than jumping here. Nothing happens. Excuse me. But what I'm going to do is I'm going to just turn off that. So now this is allowed to rotate. So I'm going to jump, try to jump. And come down, boom, and hit it. And it's going to try to rotate around that point. And it's kind of a weird center of rotation there. It's kind of a weirdly arbitrary one. Let's come back into the scene, hit that. Be tough to balance. I don't know if we can sort of get it there. But better would be to set that rotation point in a more reasonable way. So let's not auto-configure it because it's centering it according to this tile map. This is a little bit of a weird situation. You may very well want to just paint an object or take a sprite and put it in the world. But here, I'm using it potentially with a tile map here, which is a little bit more flexible when it comes to like changing the look of the object, but it's a little bit weird or counterintuitive with regards to kind of its rotation points and things. But we'll go ahead and we'll kind of fix it up here. So there and down there. And it should really be just, right, everything should be the same here. All right. That's, no. So the connected anchor and the anchor. And now, if all goes well, we should see that it will rotate around that point. So I can create something where if I come along here and I jump and I move out to this edge. Oh, well, the motor's on. Let me turn the motor off and give it. The motor's now off. That should be. again. What did I do wrong? Don't use the motor. Don't have any limits. Don't freeze the rotation. That would be handy. You'll see it'll now, hopefully. It should rotate. There we go. So it rotated freely there. So if I wanted to, I could now land on it and work my way down. Or if I had put the motor on and gave it a little bit of motor speed, does it need to be? Boom, negative 100. That's pretty. Maybe negative 20 should be enough. So we can force it to move according to that motor. So you can imagine that we have this swinging thing coming around that you could very well be like do, and you accidentally hit a trigger and the use motor comes on. And now suddenly you have to deal with this potentially swinging thing. And, it's too late, I can't push it, you know. And life gets really weird. This is another good case where maybe it's also important to be able to use limits. So let's set some angular limits to make this hinge a little bit more respectable as well. And the limits I find that they get a little bit funky with regards to what is the upper limit and what is the lower limit. So you should try this a couple of times and you'll still, eventually you'll get the hang of it. I still don't after all this time, but so I set the lower angle to 0 and the upper angle to 90. And if all goes well, that means it should only be able to, you'll see now this little line here, it'll only be able to move in this range. So the moment I put the motor on, you'll see it stops when it gets to, I guess that's 0, right? So this is kind of cool because now I can come across here, and if the motor, depending on how strong the motor is, let's see, I can kind of get it to act a little bit weird here. Maybe I make the motor speed a little bit weaker. So if I get off the platform, it will move back up. Maybe, right? So now suddenly in the world, I've got to do things like be careful about how I move along these platforms because they can be traps and pits and so on. So I can come over here, fly way up, come down, and depending on, again, what am I carrying? Or, I can trick the player to say, okay, to get things to open, I have to destroy the object that's underneath this platform to get the hinge to work, right? Yes? It is definitely not on my canvas. I don't even have a canvas. It is, so one of the things I'm working with here is basically this tile map is what has all of these joints on. So it's a little bit odd in that I've got the grid and I've got these two tile maps. You could do things where, in the world, this second one, maybe we get rid of this as a tile map and we say, all right, let's just put a normal object into the scene. And we just find some kind of good piece of art. If we go to RF Castle, actually, there's a main level build, which I think is just the sliced objects here. Yeah. So I could have, was it number 40? Nope. Well, that's good enough. All right, drag that into the scene. Put that in here. And then rotate that by 90 degrees. And everything I just did, I can then use just this sprite object for, which is maybe a little bit easier to deal with. So I could add component to that. I could say, well, okay, when I add a hinge 2D, it went ahead and added a rigid body. I want to, let's see, I guess it's going to do the right thing. It'll spin around that point. So my character could come along and, well, there's no collider on it. That's dumb of me. I would add just a normal collider, box collider 2D, and now that is something that I can interact with. So it's not really answering your question, but it's definitely not on the canvas. You can put these objects on, or these physics components on virtually any type of object. Sometimes it's nice to put them on tile maps because you'll notice the reason this is really weird is because this collider is kind of bigger than the object. So because of the transparency. So anyway, so that's an example of sort of the sorts of things you can do with kind of hinges and sliders. And let's see, there's just no end of 2D joints. The friction joints are a good one. Then you also have things like distance joints. What a distance joint is similar to the slider, but now what it's going to try to do is maintain the distance between this object and some center point. Right? So, let's see. Disable the hinge joint, add a distance joint, and we're going to give it a fairly small distance. We're going to say just 0.5. And we'll edit that collider a little bit. So now you'll see in the world that may drop or move, but it's effectively becoming a pendulum that's trying to stay within 0.5 of its anchor point. So if I were to take my character here and jump across, I've got both joints on there. I've got effectively a swinging, rotating pendulum there. Really tough to deal with. Let's come back over here. Oh, no, I see what happened. Sorry, it's not rotating. It wasn't because of this hinge joint. It was actually just because the object itself is allowed to rotate. So I kind of got the hinge for free here. It's keeping the center of the body at that distance, right? So to not get it to spin like that, I would then still go to rigid body and say, okay, don't allow rotation, and then I can press play, and I can then run over to it, or slowly run over to it, jump on top, and force it to move one way or the other, get it to swing. All the time it's trying to maintain that distance from there. So let's make that a little bit longer. That'd be kind of cool. Distance joint, we'll make it possibly 3. Oh. No, too far. All right, so we can really try to, get it to swing here. Oh, we're gonna have a hard time because it's gonna hit that other one. Let's jump, get it to move maybe. Get it unlodged. There we go. Get it to swing. I'm getting stuck with friction on that other one. All right. So again, this is sort of the idea. Without any scripting, creating these sort of environmental aspects that you can cause you have to force it to swing a certain amount and able to get it to swing from here to maybe we'll go back to our original tile map and we'll open up our tile palette and we'll say, okay, what we should have had is we'd say, all right, here's some more of this, and in our world we're going to put another platform over here that maybe our character can't jump that high, but it's going to have to jump onto this platform in the middle and get it to swing or get it to slide to kind of get from one to the other. Or maybe, again, it's got a tiptoe because there's a friction joint and that's the only thing that holds it at that level, and so on and so on and so on, right? And all of these things can be scripted as well, so you can turn them on subject to triggers or when they collide with things, or you can turn them off when they collide, or you turn them, have all sorts of inner relationships between them as well. Right. So today's assignment is to experiment with some of the joints. Try with sliders, try with hinges, try with springs. Springs, it's all about basically you have some relationship between some anchor point and a connected point and how they're resisting motion between them. Are they enforcing a certain distance that then everything can pivot around, or are they trying to keep things pulled together according to a spring mechanism, where they're doing things allowed to slide along a certain axis, or so on and so on and so on. Right? It's always about kind of limiting motion according to physical relationships. So that's why you want to use physics to move your character around rather than just changing position, so that all of those wonderful interactions will happen accordingly. All right. So if it's okay with everybody, I'm going to stop for today there and say, all right, play with joints. Think about your projects. If you already don't have a design document or some kind of saying, something in your head saying, okay, these are the things I want to explore, by all means, do that as well. And we'll kind of regroup on Friday. Sound good? All right. Thank you very much for your patience today, and have a great Wednesday, Thursday. And say hello to family and off-campus folks for all of us. Mm-hmm. I didn't really get into the spring joint. The idea behind the distance joint is that it's going to try to maintain a certain distance. So in many ways, it's sort of like, imagine having a pendulum where you just have some sort of a rigid link in between two things that can establishes, okay, they have to be a certain distance from one another, subject to the physical physics and so on. So it may pull it down, or it'll sort of eventually pendulum out at the bottom. And you can do things like say, well, okay, I'm using it as a maximum distance. You can like turn off certain limits, so it can be like more like having a string in between two objects. It's going to be just, okay, it can be this far away, but it can be closer. So that's like tying a string between two objects. That's the equivalent of a distance joint that doesn't have that is only enforces a maximum and not enforcing a minimum. And spring joints are similar to distance joints, but they don't just have hard limit when they hit the end, right? They potentially have some give according to spring physics to them. So you can assign, yep. No, because it doesn't enforce the motion along any particular axis or angle, right? It just maintains that distance. So it's sort of like, if there's gravity, it will want to go to the bottom. Just like imagine, a pendulum that it's basically take a rock and a piece of string and then hang the rock from a piece of string. That is a distance joint. And that's, well, if it's string, it's a distance joint without an enforced minimum. If you attach it to a piece of wood and just held it in the center and or something like that, where it could pendulum, then it would be a true distance joint that was with an enforced maximum and an enforced minimum, right? According to gravity. If gravity is in effect, it would. If there's no gravity, you could hit it and anything. It would just, then it'd be a dog on a chain sort of thing. Imagine that, you're some object floating weightless, but there's some point in space that it has to maintain or, be no further than that certain distance from, right? So it can move anywhere in space no further than that distance, and potentially no closer than that distance, depending on how you've configured the distance joint, right? Okay. I kind of do. I'll be around if you have any specific questions. By all means, I'll try to. I've done some short videos for folks already. I'm happy to kind of to add to those as well. To kind of reboot. Reboot. Yeah, it could just be something Unity got clogged somewhere. That's always worth a shot. First, if it's just acting plain weird, try that, and then try to debug it from there. check all your physics settings. Make sure you're using all physics 2D objects and not using physics objects. That's one thing to be aware of. Right, right. Yeah. Okay. All right. All right. Thanks. Take care. I'll check back in a little later.